BSA, body surface area. So whenever we're determining a safe dosage for a patient basing it upon their body surface area, we are using measurements of inches times pounds divided by the 3131 all square rooted, which the unit would come out as meters squares. If we're using centimeters to kilograms, that's length times the weight again. So we have length times weight, length times weight. But we're using centimeters to kilograms, we divide it by 3600 and then we square root it. Again, our unit becomes meters squared in the end. So scenario 2 says that we have a body surface area of 0.67 meters square. And it says the recommended dosage range is 15 to 25 milligrams per meter squared. So what we're going to do is we're going to take this body surface area for that patient and we're going to multiply it to the minimum, which in this case is 15 milligrams per meter squared. And if you notice, the meter square is reduced, so we set it up right. And it leaves me with 10.05 milligrams. That is the minimum. Then the maximum, we're going to take that 0.67 meters squared and we're going to multiply it by the 25 milligrams divided by that meter squared. They reduce and it leaves me with 16.75 milligrams. So this is the recommended dosage range for a person with this body surface area for a particular drug. In this case here, this is it. Now these are just examples. They're not all exactly correct, but these are examples I pulled from the textbook. So scenario 3, and forgive me on my blurriness. Okay, so on scenario 3, it says we have a child that's 41 inches tall that weighs 32 pounds. And we want to know what is the BSA for this patient. So we're talking about inches and pounds, so we're going to use this formula here. And we're going to take the 41 times the 32. So if you do it in this particular order, most of the time you'll get it right. I know that you're going to end up using a calculator for the square root, and I don't expect you to know the square root. So we're going to say 41 times 32, and that's going to give us 1,312. And then we're going to say, okay, let's divide that number by 3131. And that will give me a decimal number, which is 0.41903545519. And then I'm going to square root that number. And I'm going to round to the nearest tenths. And when I round to the nearest tenths, it gives me 6, let me write it down here, 0.65 meters squared. So a patient that's 41 inches tall that weighs 32 pounds will have a body surface area of 0.65 meters squared. Now, if you convert those to centimeters and to kilograms, your number should come out almost the same, especially when you come to rounding. It may be off by a thousandth of a point. So let's do the next example. It says I have a patient that's 140 centimeters tall. They weigh 30 kilograms. So let's use that formula. That formula says we take our weight times our height and divide it by 3,600. Make sure you can see this. So we have 140 centimeters times 30 kilograms. So we say 140 times 30 is 4,200. And now I'm going to say 4,200 divided by 3,600. And again, if you stay in this format, you stay in this process, your answer will come out correctly. And it's a repeated 6. So I'm going to put a bar over that 6. There's no need to keep going on and on and on, right? But I'm going to leave it in my calculator so that way it's going to give me a more accurate number, because we don't want to round until we get to our final answer. That's very important, especially when you're talking about a recommendation. You don't want to round until you get to the end, of all the work. And guys, I strongly encourage you to do as much as you can without a calculator and then use the calculator to check your answer. So now we are going to square root this. And when I square root that number, I get a body surface of, I'll put it right here, make sure you can see it, meters squared. Don't forget meters squared.